Hi everyone, this is Bhairab Samanta and welcome to your mathematics class Mojar Ganit. Today we are going to discuss about trigonometry. Actually, we will divide the whole trigonometric class into some small classes so that we can understand it in a better way. So this is the first class of trigonometry. In this class, we will discuss some basics of trigonometry. So let's start. So first of all, we will consider a right angle triangle. Let us say a right angle triangle ABC, right angle at C. But you may ask why we are considering a right angle triangle only, and more precisely a triangle only. There are so many types of triangle and there are so many polygons. So why we are considering a right angle triangle only? So for that we will discuss a little. So first of all, let us consider a polygon. You may consider any polygon. Here we are considering a pentagon. Let us say A, B, C, D, E. Now you can divide the pentagon into some pieces of triangles. So we divide the pentagon ABCDE into three triangles: triangle ABE, triangle EBD, and triangle DBC. So in this way we can divide any polygon into some pieces of triangles, and also any triangle can be divided into two right angle triangles. Here ABC is a triangle. We can divide it into two right angle triangles, triangle ABD and triangle ADC. Here the right angle is angle ADB and here also the angle ADC. These are the right angles. So we have seen any polygon can be divided into some pieces of triangles, and any triangle can be divided into two right angle triangles. That's why we are considering right angle triangles only. So let us jump to our today's discussion. So again we are considering a right angle triangle. So let us say a right angle triangle ABC, right angle at C. Now here are three sides which are hypotenuse, perpendicular, and base. I hope there is no confusion about the hypotenuse. Which one is hypotenuse? The side opposite to the right angle. Okay, the side opposite to the right angle, that is the hypotenuse. So here hypotenuse is AB. But the question is, which one is perpendicular and which one is base? Some of you will say that here BC is base and AC is perpendicular. But the fact is that this is not true all the time. Sometimes it is true, but however, you cannot say that BC is always base and AC is always perpendicular. Actually, it depends on some facts. So now we will discuss about those facts. Now there are two angles other than the right angle. Here you may see angle B and angle A, which are not right angle, obvious. So if we consider the angle B, then with respect to that angle, AC is perpendicular and obviously BC is base. So how we are deciding that AC is perpendicular and BC is base? Actually, the opposite side of the considered angle is perpendicular and the adjacent side, obviously there are two adjacent side, one is BA and another is BC. Since BA is hypotenuse already, so the another adjacent side will be the base. Similarly, if we consider the angle A, then with respect to that angle, obviously BC is perpendicular and AC is base. So the perpendicular and the base, they depend on the angle which we are going to consider. So now we will consider one of the angles A and B. Now we are going to consider the angle B. So obviously AB is hypotenuse and BC is base and AC is perpendicular. So we have no doubt about hypotenuse, perpendicular and base for this triangle where B is the considered angle. So let us consider the angle B as theta. Actually, this is simply a notation of the angle B. The value of theta may be 30 degree, 45 degree, 40 degree, 60 degree or any value you can consider. Okay, so actually we denote that angle as theta. So now with these three sides, hypotenuse, perpendicular and base, we may construct some ratios like perpendicular is to hypotenuse or perpendicular is to base and so on. And also you know that perpendicular is to hypotenuse, this ratio can also be written as perpendicular by hypotenuse. Ratios can also be written as some fractions like P is to H can also be written as P by H. So you may see that there are only 6 ratios with these three sides. These are perpendicular by hypotenuse, base by hypotenuse, perpendicular by base, and similarly hypotenuse by perpendicular, hypotenuse by base and base by perpendicular. You cannot write any other ratios with these three sides, hypotenuse, perpendicular and base. Now we are going to assign some name to these 6 ratios. These are most important factors about trigonometry. Actually, these are the definition of those ratios which we are going to discuss. So we will assign sin theta to perpendicular by hypotenuse. Here sin theta is a function. We will discuss about function in some another class. Actually it is some topic of some higher class, so we will discuss it in some another class. So we call it sin theta. And similarly base by hypotenuse, this is equals to cos theta, and perpendicular by base, this is equals to tan theta. Hypotenuse by perpendicular, this is equals to cosec theta. Hypotenuse by base, this is equals to sec theta. Base by perpendicular, this is equals to cot theta. Now, some of you might be confused about the fact that here sin theta, it is not the product of sin and theta. It is not so. It is not the product of sin and theta. It is a single quantity only, sin theta. Actually, without theta, sin is useless. So, if the angle B, that is considered as theta, is 30 degree, then it is sin 30 degree. Similarly, cos 30 degree, tan 30 degree, and so on. Okay. So in this way, we defined these 6 ratios: sin theta, cos theta, tan theta, cosec theta, sec theta, and cot theta. These are the only 6 ratios, and with these ratios we will find some relation, some formulae. You need to remember these 6 ratios and the definition of these 6 ratios. So I think this is a simple one, but you need to keep in mind, you need to remember these definitions, that what is sin theta, what is sec theta. Okay, these are the ratios of perpendicular, hypotenuse, and base only. But obviously you need to memorize them clearly. That's it for today. In the next class, we will discuss about some relation, some formulae with these 6 ratios, and you may see some quite easy relation like sin theta and cosec theta. These are the reciprocal to one another, and similarly cos theta, sec theta, and tan theta, cot theta. So like this, we will find some relation and some formulae with these 6 ratios. Okay, I think you understand, and I hope you enjoyed the class, and we will discuss some further in deep in the next class. So I will see you in the next class. Till then, goodbye. Have a nice day.